Have you ever stopped to think about the technology inside a simple bag of potato chips? Probably not, right? Well, it turns out there's a surprising amount of AI hiding in your favorite snack.
So let me ask you something. What's the real cost of just one extra chip? I mean, it seems like nothing, but think about it. When a factory is cranking out millions of bags a day, that one little chip, over and over and over again, it adds up to a fortune in free product just being given away.
And yeah, there's actually an industry term for this, excess giveaway, or EGA for short. It's this silent profit killer that factories are always fighting against. Every single gram over what the bag says it weighs, that's just lost money, pure and simple.
So you can see the dilemma here. It's a real tightrope act. If you underfill the bags, you get angry customers, and nobody wants that. But if you overfill them, you're literally giving away millions of dollars. So the big question is, how on earth do you hit that perfect weight every single time when you're moving at lightning speed? Well, the answer is AI.
Okay, so that brings us to part 1, building the AI's brain. Because, before an AI can start fixing things, it first has to learn what perfect even looks like for a bag of chips.
And at the heart of this learning process is something they call the golden settings. Now, the best way to think about this is like the machine's all-time high score in a video game. It's that one perfect run, the absolute best combination of settings that ever happened, where it made the most bags with the least amount of that expensive giveaway.
So how do they find this high score? Well, the system is constantly looking back at the last week's performance data. It hunts for the single most efficient run, and then bam, that becomes the new golden standard to beat. And what's really cool is, the standard only gets updated if the performance improves, so the bar is always being raised.
All right, so once it has that benchmark for perfection, the system starts building its brain. And for this, it uses what's called an artificial neural network, or an ANN. You can just think of it as a digital brain that's really good at learning from data. It sifts through thousands of past production runs, learning all the tiny, subtle patterns, connecting the machine's settings to the final weight in the bag.
Now, this digital brain is constantly being fed a live stream of data, right from the machine. We're talking about things like vibration amplitudes. Those are the RF, DF, and IF settings, which basically control how the chips jiggle and move, plus timing settings, how fast the product is flowing, the target weight, you name it. It's seeing everything that's happening as it happens.
And here's what it does with all that data. It makes a super specific prediction. See, the machine that fills the bags, it has a bunch of little buckets that all dump their chips together to make one bag. The AI's job is to predict the exact weight for each of those 9 individual buckets before they even open.
Okay, so let's get into part 2, the smart tuning loop. This is where things get really interesting. The AI stops just being a student and becomes the teacher. It enters this constant cycle of detect, predict, and correct.
So, step 1 is just detection. The AI is watching, constantly comparing what's happening right now with that perfect golden setting benchmark. It's asking, is the speed okay? Is that EGA number starting to creep up? The second there's any deviation, it's flagged instantly. And once a problem is spotted, the AI runs a quick diagnosis. It's like a doctor. First, it checks for the simple stuff. Hey, is there even enough product being fed into the machine? If that's the issue, it just pings a human on the factory floor. But if the flow is okay, then it digs deeper. It calculates exactly which one of those little buckets is the problem child and targets it for a tune-up. And this is the magic right here. Instead of a human operator just kind of guessing what to do, the AI uses its neural network to simulate thousands of possible fixes in a split second. It's running all these what-if scenarios like, okay, what if I nudge this bucket's vibration by just a tiny 0.1%? What does that do to the final weight? It finds out the absolute perfect fix and boom, sends those new settings straight to the machine.
Which brings us to part 3, constant improvement. See, this whole system isn't a one-and-done kind of thing. It's built to be a feedback loop that literally never stops learning.
And this is what that loop actually looks like in practice. So the AI makes a change, then it just watches. For 15 minutes, it gathers data to see how its fix worked out. After that, it reevaluates. Did that work? Was it perfect? Can I do even better? And if another tweak is needed, that whole detect, predict, correct cycle just kicks off all over again.
So all this automation, all this constant learning, it all leads us to part 4, the smarter factory.
Because this isn't just some cool science experiment, right? It has a huge, real-world impact on how efficient these places can be.
Because at the end of the day, it really comes back to those two main goals. This whole AI system is just relentlessly focused on one thing: slashing that expensive excess giveaway to the absolute minimum, while also keeping the production speed as high as possible. It's a total win-win.
I think this quote from the source material really sums it all up perfectly. It says, the RF recommendation engine, again, reevaluates the performance and generates new recommendations as needed. That's the key, right? It's autonomous, it's continuous, and it's always pushing to do better.
So the big takeaway here is pretty straightforward. You put this intelligent, self-correcting system in place, and what do? You get less waste, you get optimal speed, and you get a factory that is just fundamentally smarter.